In this lecture, we will learn how to describe the characteristics of frequency polygons, histograms, and bar graphs, and explain the information provided in each one. Frequency polygon graphs involve quantitative variables on the horizontal or x-axis. The vertical axis indicates the number of observations in each class of the quantitative variable. There are three features of frequency polygons I want to point out. First, the graph will have two closed ends. That is, the first and last point on the graph should have a frequency of 0. Second, the dots, which represent the number of observations in each class, are connected using straight lines. And third, the midpoint of the classes is represented on the x-axis of the graph. In this sample, the smallest class with observations is from the interval 3 through 5. The midpoint of these values is 4 because it's the halfway mark between the lower and upper boundaries. Thus, the value 4 is the x value matched with the frequency count for that class. In this case, the x value is 4 and corresponds to a y value of 2 because there were 2 satisfaction with life scores in that class. Using the data from Lecture 2a, I created a frequency polygon using Excel. Note how I added 2 additional classes to the lower and upper end of the data set, which both have frequency counts of 0. While Excel doesn't plot the actual points for each frequency value, it's easy to determine these point locations by comparing the data set to the chart. For example, the data point for the bin 62 to 64 is at a height of 7. The next class, for heights 65 through 67, has a height of 6 because there were 6 people with reported heights from 62 to 64. Finally, the values that appear on the x-axis are the midpoints of the height classes. The midpoint of 59 through 61 is 60, thus 60 is the value shown on the chart. Likewise, the value 63 is the midpoint of the second class, and as such, is shown paired with a frequency count of 7. Histograms also represent quantitative variables and use the class's midpoints for the x-axis labels. However, there is no requirement for both ends to be closed. Further, instead of using a line to mark the heights of the frequencies for each class, a raised bar is set to the height for that class. Notice the similarities between the frequency polygon chart and the histogram chart shown here. Using the height data again, I made a histogram of the data so you could compare the histogram to the frequency polygon we made earlier this lecture. The third type of frequency chart is called a bar graph. There are 2 primary differences between bar graphs and histograms. First, a bar graph displays frequency counts of qualitative or nominal level data. Thus, instead of numbers appearing on the x-axis, the bars are labeled with their respective names for the variables of interest. Second, the variable names can be ordered to show trends. In this example, the different types of liberal arts majors have been ordered from highest to lowest frequency. These graphs help readers see patterns in qualitative data. Finally, there is a gap between the bars, unlike histograms, where the bars are flushed together. This gap symbolizes the fact that the x-axis is not representing a continuous variable, where the values have meaning in relationship to one another. Also from the student survey, I have the bar graph for the degree programs or major for RSEM5100 Spring 2012 classmates. The variable, degree of program or major, is qualitative and, as such, is a nominal level variable. Thus, it doesn't make sense to ascribe a meaningful number to each type of program. To represent this fact, these bars have gaps between them, and I've ordered the graph so it is obvious to see the most common and least common majors.